the basic definition of exception is like this, that exceptions are used to signal errors or unaccepted events that occur while a program is running. Means what? That when we write a code and when we running our programs, that then sometime errors occur or some unexpected event occur. So how to handle these errors and unexpected events in such a way that the program doesn't terminate. The normal way is like this, that you see there are not the point that there are two type of errors. One is syntax error. Syntax error is such error that compiler can detect during the compilation time. It may be spelling error, it may be missing semicolon or some unrecognized character that you type. Okay, so all these type of mistakes will be detected by the compiler during compile time. So in such errors you cannot even run the program unless you fix it. So meaning to say, we are here the errors and unaccepted events means these are not syntax error. These are runtime error. So there are two types errors. One is syntax error, which is errors in the writing style, and others are runtime errors. Runtime errors are such errors which compiler cannot detect, but when the program runs, then the compiler cannot handle it. The error occur at that time, and that is such an error that compiler cannot handle. For example, if let's suppose there is a division by zero, if you look at this segment, that if let's suppose we are trying to calculate a quotient and divide the numerator by denominator, then if let's suppose the denominator value is mistakenly enter zero, then anything divided by zero is infinity. So this type of errors compiler cannot detect, but when the program runs, then compiler cannot handle infinity. So this type of errors to handle properly, this is called exceptions. So a simple definition of exception is what? Is like this, that exceptions is a mechanism to properly handle the runtime error. Okay, and the runtime errors, by properly handling, I mean that the normal behavior is like this, that whenever this type of error occurs, the program terminates and totally crash, or sometime even the computer became hang. So we want to avoid such situation, that the program should not terminate or the computer should not hang. So how to handle this type of error? Actually, it is a good programming concept, because if let's suppose you develop a big project, and that project you already give to the client and they use in the market. So the market people, the common user are not computer people, so they don't know how to deal with that. So for such type of errors, we should provide exceptions, and exception will handle all the errors in such a way that the system will not crash. So it will be like this, that you see, if let's suppose we have a function divide, okay, any division function. So in your project you will have to take care, you think that wherever you are doing division in your program, then try to provide exception. How we will do that a bit later, but just an example. So if there is a divide function, and it has two arguments, one for numerator, one for denominator. So who knows that the user will enter a zero value, or or maybe sometime the values are actually generated from other calculations. So if the denominator value becomes zero, then division by zero will result in infinity, and computer cannot handle infinity. So we should provide like this, that if you see, before doing the actual calculation, we should check that if the denominator is equal to zero, then you just display this message. Okay, otherwise do the actual calculation. So this is example without exception. So how to do the exception? Exception is like this, that when one way of handling complex error condition is with exception. An exception is a value or object that signal error. Actually, exception is a value, it's like a variable. Okay, and the variable hold the error. Okay, so the error is stored in that variable. So that exception or that variable will be thrown by the system, and there should be a mechanism to catch. So how to catch, we will do that later. So you see, in a previous statement, we just display a cout statement. It is, but it is not a, a standard way. It is not exception handling. Exception handling should be like this, that you see if there is a division by 0, okay, then instead of displaying cout statement, you should throw. You see, throw what in a double quotation is a string. So you see, it is a string exception, and this string will be thrown by the system. So where it will be thrown? It will be thrown to a try catch block. You see, it will be like this, that wherever you think that the code may generate error, meaning to say in this case any division function, any calculation where involve division, so there is a possibility that the denominator becomes 0. So put such calculations in a try block. So this is the way how to handle the exception now. So we will have a try block. Try block will enclose, you see, it is a block. It will enclose all the coding which can cause or possibly create errors. So we will write all those functions. This may be a function call, this may be a function definition, this may be a class definition or calling class members. So any such code that there is a possibility that can generate error, write in a try block. Okay, so in a try block, if the error occur, then you will have the system will throw like this. The error will be thrown like this. Okay, so if it is thrown, then throw where? Throw to catch. Automatically compiler is configured like this, that wherever there is a throw statement inside the try block, the catch block will catch it. Okay, you see, it's the words also show like this, like throw and catch. So the catch block will catch it, and after catching, it will display a proper message. And after that, you see what will happen, that after the try block, if there is no throw code or if there is no error management system, then the system will terminate. But if there is a try block and you systematically throw the exception, catch block will catch it and will display a proper message, and the program will not terminate. Okay, and if for example in the case of division by 0, the program will not terminate, and the system, the computer will not hang. So the conclusion is that wherever there is such a code which may create some problem or some error, put such code in a try block. And when you are putting in a try block, then make sure that any possibility of error, you use if statement there and check and then throw the error. So when you throw the error, it will be catched by the catch block and a proper message will be displayed. Okay, and then the system will not crash. Okay, so this is an example. Let me show you here. I think it is, yeah, this is a source code 16. Yeah, this one. Okay, you see here the same function divide, and it gets two arguments, integer and integer. In a main function, very simple example is it. So int num1 and num2 and double the quotient, because maybe the division result is not integer anymore. Okay, so simple statements here, enter two numbers, and using cin statement get the two numbers. Now you see where we are doing the division, we put that one inside the try block. Okay, inside the try block. But you see, we are not throwing, we are just using cout statement. So it means this example is not exception handling example. This is just a manual handling. Okay, so this will display this message. Okay, and then yeah, so here is no throw statement, so the catch cannot catch anything, because you see this is just cout, it is not throw statement. Okay, oh no, okay, sorry. You see, here is the divide function. Sorry, the divide function is called inside the try block. Okay, and when this, you see, the actual coding of this divide function is here. So here it is checked that if the denominator is equal to 0, then the string exception, the string message is defined, and after that throw the exception string. And when it is thrown, okay, then it will throw where? You see, note the point, the line 45, at this point the system will throw the exception, and it is well known by the compiler. The compiler already know where to throw. And who will be responsible to catch? The catch block is responsible to catch. So the catch block will get, you see, the same argument string, and the variable will get the string message, and that will be displayed. So when you are using the try, catch, and the throw statement, it will handle the error in such a way that the system will not hang, and the system will not terminate it in abnormal way. Okay, so it is easy. So then you see, by this error, the user can understand that, oh, the value that he or she entered is 0, so it should not be entered like that. So let's quickly run. Is some error there? Let's see what's the error. Okay, it was just saving problem. So enter two numbers. So for example, if I enter 12 uh, and after that I enter 0 for the denominator, so you see, error is thrown, exception is thrown. So exception is actually the error. Exception is thrown means the error is thrown. So error cannot divide by 0, and the program ended. Okay, so it's ended in a normal way. If there is no catch function, no, sorry, if there is no the throw statement here, then the actual division by 0 will occur, and then the system will hang. Let's continue. So the try catch block works like this. Okay, that if statement here, okay, and if this if statement is there, then you will have to display the message, and catch block will catch the exception. So if statement throws an exception, then this statement is skipped. You see, after, because the exception will be thrown in the calling a function, so the compiler couldn't reach to this statement yet. Okay, so this statement will be skipped, and after that the catch block, if the exception is a string, the program jumps to the catch class. So if it is a string, because this catch can only catch string exception. Okay, after that, after the catch block is finished, the program resumes here. So meaning to say, you see, here we just said end of program. Here it may be a complete program. Here maybe many statement. So it will normally come back to this point and will start execution. So what will happen? Only the division by 0 will be skipped in a normal way, in such a way that the program will not terminate. Okay, so the flow is like this, that the line which creates the error, and at that point we will use the throw statement. Then the line after that will be skipped, and if the throw data type and the catch data type are matching, then you can that the catch will execute, and after this catch block, the flow will come to just after the catch block. So there is a possibility that maybe one coding may generate a string error also, maybe in some other situation it may generate integer exception. Then you can provide another catch. So one try may have several catch, like one with a string, another with integer, and so on. Okay, and if there is no error occur, then this will normally executed, and after that this will be executed, but this will be skipped. Okay, the catch block will be skipped if there is no throw. Okay, what will happen if an exception is not caught? You see, for example, you see, what will be the situation? The situation will be like this, that let's suppose that the exception is thrown, but the exception is not of type and of type string. So if it is not of type string, this catch block cannot catch. So it will be just thrown and no one handle it. So what will happen? So you see, there are two possible ways for the thrown exception to go uncaught. One possibility. The first possibility is that the try catch block construct to contain no catch block with exception parameter, meaning to say it is not of type string to catch. Okay, the catch argument and the throw argument are different from each other. So the catch block cannot accept. One possibility that it is not caught. The second possibility is that is for the exception to be thrown from outside a try block. So meaning to say, if you call the same function one time again, the same function is the divide function. You call the same function one time again, but at that time you didn't put in the try block. Okay, in the function coding there is a throw, but you didn't call from inside the try block. Then again it will throw exception, but nobody will no block is there because you didn't call from within inside a try block. So these are the two possibilities to uncart. So to avoid these two possibilities, make sure that the catch argument and the throw argument match to each other. One possibility. Another possibility, that never call such a function which throw exception. Okay, a function which throw exception, never call that from outside a try block. So always try to call that function from inside a try block. Then if it is inside a try block, then the catch block will be responsible to handle it. Okay, the same situation. Now until now we were talking about normal data types. Okay, normal data types means division, multiplication, subtraction, etc. among built-in data types. So if this situation may occur in a classes also. So how to deal with object oriented handling? So the same concept can be applied. The same concept means the try catch block and the throwing exception. This can be applied in object oriented concept also. So how to do that? Let me show you the actual example, not from the book. So that one is here, rectangle version 1. Okay, so this one. So let's look at a rectangle.h. Okay, and the other one is this. Okay, now look at this one. This is a previous example we have studied in the previous chapters, a class, a rectangle. And you know that rectangle has length and width. So two private data members, a rectangle width and length, and constructor. Okay, not this is the exception. You see, exception management. What you see, one class is a rectangle. Inside this class, we define another class. Inside this, we define another class. So it is like nested class inside a class. And you see, class is what? Class and class name, and its body is totally empty. You see, empty class declaration. And after that, constructor of the parent class, set and width functions of the parent class, getters functions, and calculate area functions of the parent class. And the functions are defined outside the class, the set width, the set length, okay, all these. Now you see here in int main, we create object of the rectangle. So simple statement, int width and int length. Now you see, there is a possibility that when the set width and the set length functions are called, that at that time maybe the width or the length value may be negative. So if there is a possibility of negative value, then put that possibility inside a try block. Okay, and you see, when you are calling my rectangle that set width, okay, and my rectangle that set length, okay, so in that case, if when these functions are called, then okay, in the same way the other function get area also. These three functions are such functions which may create a problem. Okay, so these functions will if any one of these has a negative value, then exception will be thrown. Okay, and that exception will be what? The catch block. You see, a rectangle, and inside rectangle is a non-negative size. Okay, a non-negative size is the class. So you see, a class inside a class is showing the error nature, and the message is that a negative value was entered. Okay, so the program will not calculate and will not assign negative value to set width or to set length, and it will not be used in calculating the area also. Let me quickly check here. Yeah, you see, where there is a set width, then it checks that if it is greater than 0, then set. Meaning to say, if greater than 0, it is not negative. Then said, else throw what? Throw the non-negative. So you see, here is what? Here is a constructor of the child, not the child class. I should not use the child class, of the inner class. Okay, the non-negative size. This is what? This is the inner class constructor. So it means an object of this tiny class is created, and that is the object is thrown. Okay, so when this object is thrown, and then the catch block, you see, this catch block will catch it, and its type is what? Its type is the container class, and inside this, the scope resolution operator is for a next class. So this is the type. So whenever this error is thrown, the catch block is able to catch. So the same concept you see in a set length, object is created and the object is thrown, and the catch block is able to catch. So you see, catch block in this case is 1, but the throws possibilities are many. Okay, the throw possibilities are many. You see, like here also may be possible, and here also may be possible. So at any place when this type of exception is thrown, this catch is responsible to handle with that, and a proper message will be displayed. Okay, and the calculation will not apply. So let's run enter rectangle width. Okay, so I am typing normal values like 6 and then 12. Okay, so at this time the area is calculated and displayed. Okay, but if I run again with the negative values, okay, so the width is, let's suppose, -6. Okay, so and if I display the length, enter the length 12, so width is negative, length is positive, but you see no calculation applied, and the error message displayed that a negative value was entered. So meaning to say, the user can understand that why we didn't get the area, because a negative value was entered. So if you apply negative value in area calculation of rectangle, it is a big mistake. So to avoid this mistake in a proper way, so this is object oriented style of exception handling. The main objective of exception handling is what? You see, this way of reporting error is much more graceful than simply aborting the program. Aborting program means that the program will terminate in an unexpected way. Okay, so any code that uses the rectangle class must simply have a catch block to handle the negative exception. Okay, and the next program shows example. This this one I think we already did. Yeah, we already did this one. Okay, multiple exceptions. Okay, multiple exceptions. The program we have studied so far test only for a single type of error and throw only a single type of exception. Why single? Because we only define one class there. Okay, and we are handling only negative value. There may be possibility to handle other possibility. For example, in the same example, you are handling negative value also, and in the same example, you are handling zero value also. So that will be multiple exception then. In many cases, program may need to test for several type, of course. Yeah. So at that time, you can provide several exceptions. So the conclusion is like that you can provide several exceptions. Yeah. So it's the same thing. Yeah. Okay. This one, notice that in the definition of the set width function, the instance of negative width class is thrown. Oh, this one is a bit different. This one is a bit different. The difference is this, that you see for everyone, it specifically shows that if the width is less, then you throw this one. No, it's the same one. Yeah, maybe here is the difference. Negative length catch. Yeah, here is a difference in this one. The difference is what? You see, one try block and one catch block with argument of what? Negative width. Okay, and another catch block with negative length. So one try block and two catch block are there. Okay, so this is which program? 16.3. Okay, let me open that one. This is version 2. Okay, so let's check this. Yeah, let's go through the same thing. Rectangle class, width and length, negative width. You see one class. This time two classes are defined. One tiny class for negative width and another tiny class for negative length. Okay, so you see separate classes. So this is the container. We should not use the parent class because that is specifically used in inheritance. So the container class and the inner class are the outer class and the inner class. So what is the difference? Two different tiny classes are defined, one for width, one for length. So you see, in this way you can define as many possibilities as you want, for width, for length, for zero, for any other possibility. Okay, so when you go to the set width, it throws the negative width constructor, and when there is a set length, it throws a negative length constructor. Okay, and the catch is 1. Why the catch is 1? Because the type is 1. The rectangle, no, catch will be also 2, because one is negative width and one is negative length, so the catch will be also 2. So what is the catch? Let's check this one. Yeah, so you see here the all the coding put in the try block, and now two catches are provided because we have two different possibilities. What's the benefit of this? Because previously the error message was that negative value was entered, but it was not clear that the negative value was for width or the negative value was for length. So now is much more clear. It specifically tell you that which value is negative. If the width is negative, you will get this error, and if the length is negative, you will get this error. Okay, let's try to run this one. So enter width. So I am entering this one with the negative 6. Okay, and I am entering the second one positive length. Okay, so you see the error message is very specialized. A negative value was given for the rectangle's width. So you see, it is very clear, and this is actually the objective of exception handling, that you generate such an error that is much easier for the user that what happened. Okay, so this time uh, exactly tells that the width value was negative. If I run again and enter the width this time positive and the length negative, so you see another specialized error, that a negative value was given for the rectangle's length. So then anybody can understand what happened. Okay, so meaning to say that in if you want to handle many exceptions, then define many classes. Okay, define many classes, like a tiny class for width, tiny class for length, tiny class maybe for error. Okay, you can define a simple another class. You can say like this, class, oh sorry, not this class uh, zero error. Okay, and after that you can just provide empty body of this, and you see this class. Now you can check actually during the here, that you can check else if the w equal to 0. Okay, then throw the other one. Let me do here, then throw what was the class name? 0 error. So it's constructor, throw this, create constructor of this. Okay, else the last one will be else. Okay, so else, no, sorry, this one we should cut from here. No, if it is greater than 0, then you do the calculation. If it is 0, then throw this, else this. Okay, you can specifically check this one also. Okay, so you see we change for the width width class. So whenever we give the value of width, we can check the second one. So in that case, let's go to the program and provide another catch block. Okay, and that catch block will be what? The zero error. Okay, the zero error type. And here we can type errors a negative now a zero value was given for the rectangle width, not for the rectangle length, because we just applied there. Okay, so now save these changes, and let's check. You see, this time for the width I'm entering 0. Okay, and for the length I'm entering 12. So you see, oh, what's wrong? What's wrong? Let's go and check. There is something wrong. Else if, I think I should use proper curly brackets, then we can see properly. Then here is else if w is equal to 0, then throw this. Okay, else okay, if it is equal to 0, if it is greater than, oh, so you see here, this condition is wrong, then we need to change. Actually coding was correct. So if you see, if it is check that if it is greater than 0 or equal to 0, then assign. So this time just remove the equality. The problem was here. Okay, so if it is greater than 0, then assign. Okay, else again check if it is equal to 0. Okay, then throw this error, else throw this error. Yes, now is okay. The problem was in the first condition. Now run again. So enter width 0, length 12. You see, and a 0 value was given for the rectangle width. So you see, we can check 0, we can check negative in this way. Okay, so what we did, we just simply define another extra tiny class. Okay, so in this way you can apply. I hope you get. So let's go through. Next is what? Okay, next one. Until now, you see what we are doing. The program, when we run it, let me run one time again from this perspective. When we let's save again. When we run it, fail to, something is wrong. What? Yeah. So let's run once again. The problem is what? You see, if I enter 0 and another value, you see what happened? I get a proper message, but what happened? The program still ended. I didn't get a proper value that I was supposed to get. So I just give a proper error, that's all. Now the question is that how to force the user that no, must enter correct value. Okay, this one is talking about that, how to recover from an error. So in this case, you see what it does this time. Let me open in a yeah, this one, program 6 point this. Yeah, let me open this one. Yeah, you see what, the only thing is that whenever we were trying to we were using the try catch block. Okay, we put the try catch block this time in a while loop, meaning to say it will run again and again and again until you get a proper value. So you see rectangle width, if something happen here, okay, if something happen here in this line, compiler and the exception is thrown, then what will happen? Then compiler will come to this place and the try again will be false again. So while it is false, it will okay, sorry, it will if something happen, exception will be thrown, and exception, when exception is thrown, compiler will jump to the catch block. okay, and the value of try again didn't change, it remains true, okay, because at the beginning it is true, it remains true. So as long as the value of try again is true, okay, it will force the user to enter again and again. Okay, you see the same for set length. So this is the mechanism to use to force the user to enter correct value unless uh, unless the system get a correct value. So you see, if I run this one, set length doesn't, what's wrong? Let's save it. Yeah, it's okay. So if I enter negative value here, -6 for width, and let's suppose 12 for oh, you see, okay, negative plus value for this. You see, it says enter, please in, okay, enter a rectangle width, please enter. Oh, I didn't read the message properly and enter a wrong value. Okay, let's run once again. So you see, I am entering -6. As I enter the -6, I'm getting, please enter a non-negative value. I am entering again -9. Please enter a non-negative value. So you see, it doesn't leave me to go further unless I enter a positive value. Okay, -12. Please enter non-negative value. So if I enter positive value, then yes, it go for the length now. So for the length, if I enter -12, you see it says please enter non-negative value, -10, again please enter non-negative value unless I enter a positive value. Then the area will be calculated. So you see what happened now, the exception is managed in such a way that not only handles the wrong value, but force also the user to enter a correct value. So not only handling but recovering from the exception also. This is called recovery from the exception. Okay, so how to recover? So the recovery is like this, that you will manage the coding in such a way that the user will not proceed until the system get a correct value. This is called recovery from the error. Okay, so the technique is that they put the try catch in a while loop. Okay, so whenever, because after the while, after the catch block, the computer comes again back to the same point. Okay, so when it comes to the same point, it is already in a loop. Okay, and in the loop is while loop, as long as, unless the loop variable become false. Okay, a loop variable will only become false if there is no exception in this calling function. If no exception, this statement will run smoothly, and then computer will come to this line and the loop will become false. And when it become false, then it will come to the next block of code. You see all these, and then it will check for the next one, and so on, like that. Okay, extracting data from the exception. Now you see, this time uh, we don't know that what value was entered. We only know that negative value was entered, but we don't know exactly what was the value in the exception. Not the point, not the point. The point is that we only handled the exception like 0, negative value. So we only displayed a message that negative value was entered. But if you want to tell the user that, you see, the negative value was this, like -6, so even not only handle the exception, but extract the value from within the exception and show to the user that, you see, this was the value which is wrong and you entered a wrong value. So what to do? The only changes will be in the tiny classes. The tiny classes, you see here, that class negative width. So it defines a value. Previously was empty body, this time is no empty, because why? We want to store something. So if you want to store something, then you need to provide its own variable. Okay, so double value, and when the constructor is generated, the value is assigned to its value. Okay, and there is a function get value function. Okay, so in the same way, for the when the catch block, when it throws, you see the throw will be like this, that previously was throw negative width, but the brackets were empty. It was default constructor, but this time is not default constructor anymore. This is overloaded constructor. The overloaded constructor will pass this value to the variable defined inside the tiny class. Okay, and that will be stored properly, and once it is stored, then we know what okay, once it is stored, then we can get that value back. And once we get back, then actually we can display to the user that you see you entered this value, and that will be in this way. You see that error was entered, and you see e dot get value. The get value function is called here. So when we call the e dot get value function, we can get the value back and display to the user that you entered this value. Okay, so this is another version. So this one is in version 3. Okay, let me quickly run that one also. Yeah, so rectangle h, you see this time the negative width uh, class, the inner class, is not empty. It has a private data value to store the value, and a public member function to read the value. No, sorry, the first the constructor, and then to read back the value, get value, getter function. Okay, the same for negative length value, it's overloaded constructor and the getter function. Yeah, all these are here. So these functions are not defined here. Okay, so this one, yeah, mostly it doesn't work. You see, let me show you one thing more also. This is for your knowledge, that you see here I included the rectangle.h. Okay, but this rectangle.h is included in the rectangle.cpp. Okay, so, and these are called here. So here I think we should not, yeah, okay, so this cannot work there. We should copy this one. Okay, let me show you first. You see, if I run this coding here, let's save it. If I run this coding will not work. You see, the problem, it says that undefined reference for the function set width and the set length. What does it mean? That actually the compiler cannot find these two functions, that where these two functions are defined. These two functions are defined in the separate file, okay, which is not actually linked with this one. So the simple way, just copy from here. Okay, copy from here if you are using the same source code downloaded from the book, and paste after the body of the class, and then save this .h file now, and .h is now linked with that. Now if I run, okay, so it works now. So you see, this one is extended version. It will not only handle the exception, but will generate proper message, and then will extract the value from that exception and will display to the user. For example, if I enter -6, okay, you see, and enter a negative length, let's suppose the length is, let's suppose, positive. Okay, so you see error happen. What is the error? You see, -6 is an invalid value for rectangle width. So you see, even we display the value back to the user that you entered this value, which is wrong. Okay, and in this program there is no the recovery from exception concept, meaning to say we didn't put the coding in the loop. You can put in the loop also and provide this mechanism if you want. It is also possible. Okay, in the same way, if you give a negative value for 12, you can see that one also. And let's run once again. So the width is +6 and the length is -12, let's suppose. So you see, this time it says properly that the -12 is an invalid value for rectangle length. So we not only handle the exception properly, but we extracted the value also from that exception. Okay, another concept quickly. This is given here. You see, exception handling bed allocation. This is very important one actually, and we are mostly using, and this exception is generated when we are using the new operator. Okay, you know, most of the times we are using new operator to dynamically create objects. Okay, so if, let's suppose, the new operator couldn't run successfully, then it will create this exception. So to handle this exception, you need to include this file. This header file you will include, and after that you will use the try catch block. Inside the try block you will use the new operator, like a new object you want to create. Okay, so whatever coding related to new you will put here in the try, and you see the catch type is what? Bed allocation. Bad allocation means the memory could not allocate it to the new operator, the newly generated object. Okay, memory could not assign. Okay, so then the catch block will display a message. The program is actually given, but I don't think so that you will be